Hello everybody, this is a video tutorial for Lab 4 for Physics 100 at UBC. Today we're going to be doing a lab that examines the periodic motion of a pendulum. In this case it'll be the phone itself, and we'll be using the accelerometer sensor in order to collect this data of the motion. In order to collect this data, we're going to need to access the accelerometer sensor of our phones, and you can do this on both Android or iPhone. And to get this data, we need to go to our respective app stores to find an application. For the Android, you'll be using the Play Store, and for iPhone, you'll be using the App Store. So if we go to the Play Store, you can do a search for accelerometer, and as you can see, the third row down, we'll see the Physics Toolbox Sensor Suite. This is available for both platforms, so this tutorial will apply to both Apple and Android users. So we click that, we install it, and the application will show us a variety of data that's being collected by the phone. Now, there's a lot of sensors on your phones that this application will actually be accessing, so we want to make sure we have the right sensor. So in the context menu in the top left, we're going to open that up, and we're going to see all the different kinds of sensors. The one that we want is a linear accelerometer. So as you can see, the phone is now collecting acceleration data. So it's going to record it in 3 dimensions, in X, Y, and Z. So if I move my phone from left to right, as it's facing me, and I do this fairly fast, you'll see that the red bar is moving, and so that's the left to right motion is the X motion. If I were to go up and down with the phone, we're going to excite the green bar, and that's the Y axis. The Z axis is going to be front to back. So, in order to collect very accurate data, we're going to want to play with the settings a little bit. So we'll go to the top right. Under displayed axis, you have a variety of options. You want to select X, Y, and Z, just so that you can collect all of the data. You'll only be really using one, but it's good to have them all available just in case. Under CSV timestamp format, you're going to want to select elapsed time. This simply is just going to make it so that the data you collect will start at t equals 0 from the moment you started collecting the data. The CSV is a format that Excel can open, just so you know. Under sensor collection rate, you're going to want to click fastest. This is just going to give you the most accurate data that your phone can offer the application. Keep the screen on is a good option to select, and you can also calibrate the accelerometer. So if we go through that, you'll simply put the phone flat and hit calibrate on a desk, for example. And this just gives you a calibration. So now you're ready to collect very accurate data. I'll show you later how to actually get this setup for the experiment, but for now what I'm going to do is just oscillate the phone as if it were on a pendulum, and I've collected some data. Now that your phone is set up, you can begin collecting data. So you'll notice that there is a red circle with a plus in it. That's the button to begin collecting data. So let's oscillate the phone as if it were on a pendulum. And as you can see, there's sinusoidal behavior. Now to record this data, we would hit the plus and begin recording. And then once we're done, we can hit the stop button and name the file name. Hit OK, and email it to yourself. So for example, I'm just going to send it to myself. From here, you will download this on your computer and put it into Excel. Now that the accelerometer is set up on your phone, as you can see on this, you can affix the phone to some sort of pivot and take it, move it, and just let gravity oscillate it. And the accelerometer will collect all the acceleration data, and from this you should be able to get the period. Let it go. Remember to hit the record data button before you do this. And there you go. That's all you need to do to collect the data. Now that we've collected the data from our phone, we can start analyzing it in Excel. So the phone outputted a CSV file, and this is it, opened in Excel. In order to begin analyzing this data, we need to understand what's in these columns here. So the phone has recorded the time, the acceleration along the X, Y, and Z axis, and then the magnitude of the acceleration. So if we wanted to analyze this data, we would first have to choose a column. So I'm going to choose the Y dimension because that's how I oscillated the phone. And I'm just going to select all this data. There we go. Once it's all selected, I'm just going to go to the scroll bar and go all the way back up. And then click Insert, and then go to Insert Line Chart, and pick Line with Markers. And there you go. Now you'll notice that the x-axis, or rather the time axis, is in the column number, not in time. That's because we have not chosen a time data set. So what we'll do is we'll go to Select Data, and we'll click Edit under the horizontal axis labels, and we'll simply pick the time column and select all the data points there. Then hit OK. And then OK. Then we go back to the chart, or rather the plot, and you'll notice now that the time dimension is actually in time. So to make this more appropriate for scientific analysis, we're going to add axis titles. So we do that by hitting the plus and going to axis titles. Now we can label each axis. So this is the time, and we'll record that in seconds because that's what it's recorded as, and the acceleration. Remember to always include units. And then the title. Now you'll know that there's some aspect of the data here that is a bit corrupted due to the fact that I had stopped the phone from oscillating. So we could, if we wanted to, remove this part of the data. So this seems to end at around 17.5 seconds. So if we wanted to remove that part of the data, we could just go to that time, 17.5, so right around here, and then just hold Shift and then select all the data. So I'm holding Shift to select all these cells. And then hit delete, and it's all gone. And when we return to the plot, you'll notice that that part of the data has been removed. Now this data is ready for analysis.